Every clear night, the same illusion returns. A pale river of light spills across the darkness, and for a moment, it feels simple. That glowing band must be our galaxy. That must be the Milky Way. It feels complete. It feels familiar. It feels like something the human mind can almost hold. But that feeling is false. Because what you see in the night sky is not the Milky Way in full. It is not even the Milky Way as it truly is. It is only the brightest, thinnest, most misleading fraction of something vastly larger, darker, older, and far stranger than most people ever realize. The Milky Way is not a picture hanging in the heavens. It is not a neat spiral floating at a safe distance where we can admire it from the outside. It is a place we are trapped inside. And that changes everything. Because once astronomers stopped trusting the sky at face value, once they began measuring the motions of stars, tracing the gas, following invisible gravity, and mapping the hidden architecture beyond the light, the galaxy we thought we knew began to dissolve. The bright band was only the surface. The visible stars were only the skin. And beyond them was something larger than sight. A layered structure of dust, gas, dark matter, ancient wreckage, companion galaxies, warped outer regions, and a black hole buried at the center of it all. Tonight, we are not just asking how big the Milky Way is. We are asking something more unsettling. What if almost everything you imagine when you think of our galaxy is only the illusion created by standing in the wrong place? What if the Milky Way you have in your mind is not the Milky Way you actually live inside? Because the deeper astronomers looked into our cosmic home, the stranger that home became. And by the time you reach its center, you may not feel like you understand the Milky Way better. You may feel like you understand just how little of it was ever visible to begin with. For most of human history, the Milky Way was just a mystery written in light. A hazy white path across the night. A luminous scar through darkness. A band of stars too broad to count and too distant to touch. Ancient cultures gave it stories. Navigators followed it. Poets admired it. And for a very long time, that was enough. Because from Earth, the Milky Way does not look like a structure. It looks like atmosphere, like a glowing wound in the sky, like a cloud of light that belongs more to myth than to geometry. Even now, that first impression remains powerful. When people imagine the Milky Way, they often picture the bright streak overhead, or a clean artist's rendering of a spiral galaxy seen from above. Something symmetrical, something legible, something complete. But that is not how the Milky Way is experienced from where we actually are. We do not see our galaxy from above. We do not see it from the side. We do not see it as a finished object at all. We see it from within, inside the disk, inside the dust, inside one of its lesser spiral features, inside the confusion created by distance, angle, obscuration, and light itself. That makes our perspective deeply misleading. A nearby bright star can feel more important than a distant region containing millions of stars. A thick cloud of dust can erase entire sections of the galaxy from view. Dense star fields can make one direction seem richer and another seem emptier, even when the deeper structure is far more balanced than our eyes suggest. The Milky Way is not lying to us, but it is not presenting itself clearly either. Imagine trying to understand the shape of a forest while standing in the middle of it at night, with fog drifting between the trees. You would see trunks, shadows, openings, density, maybe a distant glow, but you would not see the forest as a whole. You would not know where it truly began or ended. You would mistake your local view for the full structure. That is what human beings face with the Milky Way. We are studying a galaxy from a position buried inside one of its internal lanes, looking through gas, dust, and stellar clutter, trying to reconstruct a shape too large to be seen directly. That is why the Milky Way is harder to understand than many galaxies much farther away. A distant galaxy can be photographed in one frame. Our own cannot. A distant spiral can be admired as a whole. Our own must be rebuilt piece by piece, signal by signal, wavelength by wavelength. And once that reconstruction began, something surprising happened. The Milky Way started getting bigger, not because the galaxy itself changed, but because our definition of what counted as the galaxy kept expanding. The bright band in the sky was not the whole of it. The disk of stars was not the whole of it. Even the graceful spiral image was not the whole of it. Again and again, the edge moved outward, and every time it did, the Milky Way became less like a visible object and more like a layered kingdom of fading light and hidden gravity. Which leads to the first unsettling truth. Where most people think the Milky Way ends, the real Milky Way has only just begun to disappear. Human eyes trust brightness. That is one of our oldest instincts. Where there is light, we assume there is presence. Where light fades, we assume the thing is ending. Beyond that, we imagine emptiness. That instinct fails almost immediately in astronomy. Because galaxies do not end cleanly. They do not have walls. They do not have shorelines. They do not have a final illuminated edge where structure stops and space begins. They fade. And once astronomers began tracing what lies beyond the bright stellar body of the Milky Way, they found something much broader and much stranger than a simple disk of stars. First comes the stellar halo. This is not the part of the galaxy that dominates photographs. It does not blaze like a spiral arm or gather into dense visible lanes. It is sparse, ancient, diffuse. A vast surrounding volume in which old stars move along elongated, tilted, and often chaotic paths, far above and below the main galactic plane. If the disk is the visible body of the Milky Way, the stellar halo is its ghostly outskirts. The stars here are often older and chemically poorer than many stars in the disk. They carry a different memory of time, a memory from earlier epochs of the galaxy. A memory from smaller systems that were pulled in, disrupted, and absorbed. The halo does not glow like a shell. It does not surround the Milky Way with a bright outer ring. It is too thin for that, too scattered, too quiet. A traveler in the halo would not see a smooth outer border. They would see darkness interrupted by distant stars, globular clusters hanging like ancient relics, and enormous reaches of near emptiness, where the galaxy is present only in the faintest possible way. Already, that changes the meaning of galactic size. The Milky Way is not just the bright disk that dominates so many illustrations. It extends farther, becomes more fragile, and continues into a much wider region than the eye first suggests. But the halo of stars is still only part of the story, because the most important outer structure of the Milky Way is not made of visible stars at all. It is made of something we cannot see directly: dark matter. This is where the galaxy becomes harder to picture and easier to underestimate. Stars and gas orbit the Milky Way in ways that do not make sense if visible matter is all that exists. Satellite galaxies move as though they are caught inside a much deeper gravitational structure. The outer parts of the galaxy behave as if they are embedded in a vast unseen mass, far larger than the bright disk alone would ever imply. That is why astronomers infer a dark matter halo surrounding the Milky Way. Not a glowing sphere, not a visible cloud, but a massive hidden scaffold extending far beyond what starlight reveals. Without it, the motions do not work. Without it, the galaxy as we know it does not hold together in the same way. The Milky Way, then, is not just larger than it looks. It is larger in a way that light alone cannot show. And then there is another layer: gas. Not only the gas inside the disk, where stars are born, but gas surrounding the galaxy in a broad, diffuse envelope, sometimes heated to extraordinary temperatures, sometimes cooler, sometimes clumped, sometimes stretched thin across immense regions. This is part of what astronomers call the circumgalactic medium, a phrase that sounds clinical, but what it describes is astonishing. The Milky Way does not merely shine. It circulates matter. It exchanges matter. It breathes. Gas can be pushed outward by stellar winds, supernova explosions, and energetic events near the center. Other gas can cool, fall inward, and eventually help form future generations of stars. The galaxy is not a sealed island of light. It is part of a continuous conversation between the visible structure and the darker space around it. This invisible envelope is difficult to see directly. Often it reveals itself only through the way it absorbs light from much more distant sources, or through faint signatures in X-rays and other wavelengths. In other words, the Milky Way keeps growing in our understanding not because we see more of it with our eyes, but because we keep discovering more of the matter and influence hidden beyond the light. So where does the galaxy end? At the edge of the bright disk? No. At the outer reach of the stellar halo? Not exactly. At the fading extent of the dark matter halo? Even that depends on how you define the boundary. The truth is more unsettling than a neat answer. The Milky Way does not really stop. It thins. It loosens. It fades into a regime where borders become uncertain and structure becomes more about influence than appearance. That alone would make our galaxy stranger than most people imagine. But the Milky Way is stranger still. Because even after the bright disk, the stellar halo, the gas, and the invisible mass, one of the clearest ways to measure the true scale of our galaxy is not by looking at what belongs to it internally. It is by looking at what remains trapped in its gravitational reach. The Milky Way is not alone in its immediate darkness. It has companions, not merely distant galaxies scattered far across the universe, but smaller neighboring galaxies moving within its gravitational domain. Systems with their own stars, their own histories, their own dark matter, their own fragile identities, all caught inside the larger environment shaped by the Milky Way itself. The most familiar are the large and small Magellanic Clouds. For observers in the southern hemisphere, they appear as detached, luminous patches in the sky, like little islands of mist. For centuries, they were simply strange visible companions to the night. Now we know what they really are. Dwarf galaxies, external star systems, real galaxies, not pieces of the Milky Way, but nearby structures moving within its broader gravitational sphere. They matter because they make one truth impossible to ignore. The Milky Way is not just a thing, it is a host. Its gravity extends far beyond the brightest stars of the main disk. It reaches outward into a surrounding population of lesser systems, and those systems help reveal the true breadth of our galaxy more clearly than starlight alone ever could. And the Magellanic Clouds are only the beginning. Around the Milky Way move many smaller dwarf galaxies. Some are faint and spheroidal, some still contain gas, some continue to form stars. Some are so dim that they were only discovered in recent surveys, suggesting the galaxy may have even more companions than we once realized. These satellites are not decorative. They are participants in an ongoing gravitational history. Some orbit quietly. Some are disturbed. Some are being torn apart. The Sagittarius dwarf galaxy is one of the clearest examples of this slow destruction. As it moves through the Milky Way's gravitational field, tidal forces stretch it, strip its stars, and draw them into long stellar streams wrapping around the galaxy. It does not vanish all at once. It is gradually unmade. That image changes the character of the Milky Way completely. Because it means our galaxy is not simply sitting in darkness like a glowing ornament. It is actively shaping a surrounding domain. It captures, it disturbs, it absorbs. Its history is written not only in the stars it formed, but in the smaller systems it has dismantled and added to itself over time. The stellar halo itself may preserve the remnants of many such events. Old stars, globular clusters, and streams may all carry traces of galaxies that once existed separately and were later drawn inward, stretched thin, and folded into the Milky Way's outer structure. So, when we speak of the size of our galaxy, we are not only speaking of a disk measured in light years. We are speaking of a territory of gravitational influence, a domain large enough to keep a court of smaller worlds in motion around it. That makes the Milky Way feel grand again, powerful again, dominant again, but only for a moment. Because the next truth removes even that comfort. A galaxy large enough to rule over many smaller companions still is not a cosmic center. Because the Milky Way itself is only one member of a larger family. And beyond that family lies something larger still. At human scale, the Milky Way feels infinite. At stellar scale, it feels overwhelming. At galactic scale, it feels large. At cosmic scale, it becomes local. This is one of the hardest shifts for the mind to accept. Because once you move beyond the language of our galaxy, the Milky Way begins to shrink very quickly. It belongs to a small gravitational collection called the local group. This is not the entire nearby universe. It is only our immediate galactic family, a loose association dominated mainly by the Milky Way and Andromeda, with Triangulum as another important member, and many smaller galaxies scattered through the shared environment. Already, our galaxy is no longer the whole stage. It is one large participant in a local system. Andromeda is not a minor companion. It is a galaxy of comparable significance. In some ways, it may even be somewhat larger than the Milky Way. The two spirals dominate the local group together, separated by immense distance on human terms, yet close enough in cosmic terms to remain locked in a long gravitational relationship. That alone is enough to break the illusion of centrality. But the shrinking does not stop there. Because the local group is itself embedded within a larger regional structure, part of a nearby landscape of galaxy associations, filaments, and flows that connect one cluster and grouping to another across enormous scales. And when astronomers map the universe on still larger scales, they find something stranger than a random scatter of galaxies. They find structure, not a uniform dusting, not an endless smooth fog, but a cosmic web, long filaments of matter, dense intersections, broadsheets, immense voids where galaxies are far sparser than average. Gravity, acting over billions of years on tiny irregularities in the early universe, has shaped matter into a colossal architecture. Galaxies gather along these vast filaments and around denser nodes. They do not simply float alone in all directions, they belong to a larger pattern. And the Milky Way is one luminous point inside that pattern. Not the center of it, not the purpose of it, not its defining structure, just one address. This is where the emotional scale changes most sharply. Because the Milky Way is still enormous. It still contains hundreds of billions of stars. It still stretches across impossible distances. It still governs dwarf galaxies, and drifts inside a history of mergers, streams, and invisible mass. But now it is set into context. Now it looks less like the universe around us, and more like one ordinary galaxy among many, positioned in one local branch of a much larger cosmic arrangement. The old image of centrality collapses. Our galaxy is not the stage built for life. It is not the obvious focus of the visible cosmos. It is not even the central object of its own local group in any absolute sense. It is a location, a large one, a beautiful one, a meaningful one to us, but still only a location. And that makes the next truth even more powerful, because not only are we not in the center of the universe, we are not even in the center of the Milky Way. There is something quietly humbling about our address inside the galaxy. The sun is not near the center of the Milky Way. It is not embedded in the densest part of the disk. It does not orbit in the galaxy's most dramatic region, and it does not reside in one of the Milky Way's grandest spiral arms. Instead, the solar system lies in a smaller structure, often called the Orion Arm, or Orion Spur, a local spiral feature between larger arms. That detail sounds modest, because it is, and that is exactly why it matters. The Orion Arm is real. It contains stars, gas, dust, and star-forming regions. It is part of the living architecture of the galaxy. But it is not the kind of place people imagine when they instinctively want home to be important. We are not in the center. We are not in the brightest lane. We are not in the defining core of the galaxy's design. We are in a side feature, a meaningful side feature, yes. A beautiful one, yes, but still a side feature. This becomes even stranger when you realize how much of human perspective depends on that location. Because the solar system's position shapes everything we see. We observe the Milky Way from inside the disk and inside a minor spiral structure, looking through intervening dust and crowded layers of stars. Nearby regions can dominate our perception. More distant regions can disappear behind obscuration. What seems like the galaxy from Earth is heavily filtered by where we happen to be standing inside it. In that sense, the Orion Arm is not just a location. It is the lens through which civilization first encountered the galaxy. And that location may also be one reason complex observers had time to appear at all. The solar system is far enough from the violent central regions that it avoids some of the most extreme crowding and energetic instability closer to the core. At the same time, it is deep enough within the main disk to belong fully to the galaxy's ongoing history of stars, gas, and heavy elements. It is not empty here. It is not perfectly safe here. But it is calmer than the inner galaxy. A middle ground. Not chosen, not designed. Just one workable region in a vast spiral system. That is one of the most important corrections astronomy has ever forced on human instinct. We do not live in a privileged cosmic seat. We live in an ordinary but survivable district of an ordinary but magnificent large galaxy. And if that feels humbling, it should. Because even inside the Milky Way, we are not especially central. Human beings did not wake up at the throne of the galaxy. We woke up in one of its side streets. But the farther inward you move from that side street, the more the galaxy changes in character. The calm starts to disappear. Density rises. Dust thickens. Gravity gathers. And the Milky Way begins to reveal a far more compressed and ancient heart than the sun's quiet neighborhood ever suggests. From the solar neighborhood, the galaxy can feel spacious. Stars are separated by enormous distances. The local region contains many stellar systems, but not in the suffocating densities found closer to the core. There is structure, motion, and history here, but also a sense of breathing room. That feeling does not survive indefinitely. As you move inward through the galaxy, the Milky Way becomes denser, stranger, and harder to read. Even the outer disk is more complicated than the classic image suggests. It is not perfectly flat. It is warped. It flares. Its gas reaches farther than many of the brightest stellar regions. The disk bends and thickens in subtle ways, shaped by interactions, internal dynamics, and the influence of the broader gravitational environment. The galaxy is already less tidy than the simple spiral image implies. And then the inner regions begin. The farther inward you go, the more the Milky Way stops feeling like a broad wheel of light and starts feeling like a system under compression. Gas becomes denser. Dust obscures more of the visible light. Stellar populations thicken. Motion becomes more tangled. Structures overlap. The broad simplicity of the outskirts gives way to a more concentrated internal anatomy. There is the bar, a stretched central structure of stars cutting across the inner galaxy. There is the bulge, a dense central swelling containing older stars and a very different environment from the outer disk. There are dust lanes, gas flows, star-forming regions, and hidden internal geometry that visible light alone cannot reveal. This is why the inner Milky Way is so difficult to reconstruct from Earth. We are not observing it from a clean external view. We are looking toward it through the clutter of our own galaxy, through intervening stars, through obscuring dust, through all the complications of trying to map a city while trapped inside one of its outer districts. That is why infrared astronomy matters so much here. Radio observations matter. Stellar motions matter. The inner Milky Way must be assembled through evidence more than through direct sight. And what that evidence reveals is not a calm center. It reveals a gathered center. The outskirts of the galaxy feel extended. The inner galaxy feels concentrated. The outer Milky Way drifts and thins. The inner Milky Way compresses and builds. This is not merely a visual effect. It is a change in physical character. The density of stars, gas, and gravitational complexity rises. Histories overlap. Orbits become more chaotic. The galaxy's central machinery becomes harder to ignore. If the outer galaxy feels like geography, the inner galaxy begins to feel like process. Like a place where matter is being driven, recycled, concentrated, and repeatedly shaped by forces stronger than those dominating the solar neighborhood. It is here that the Milky Way feels oldest. Not because the outer disk is young, but because the center carries a different weight, a sense of accumulation, a sense that the history of the galaxy has been gathering inward for billions of years. And buried inside that gathered heart lies the object people know best by name. A dark point of enormous mass. The place where so many popular imaginations assume the galaxy must somehow end in chaos. But the truth, as usual, is more precise and more disturbing. Because the center of the Milky Way is real. It is extreme. It is powerful. But even that center is not what people think it is. At the center of the Milky Way lies Sagittarius A, a supermassive black hole, an object with a mass of roughly 4 million suns compressed into a region small enough that ordinary language starts to fail. It cannot be seen directly in the normal sense, not because it is absent, but because black holes do not shine by having a surface. They reveal themselves by what they do to the matter and light around them. And in the case of Sagittarius A, the evidence is profound. Astronomers watch stars near the galactic center, orbiting something compact, massive, and hidden. Those stars move too quickly and too tightly for any ordinary cluster of matter to explain. The only explanation that fit the data was a supermassive black hole. That discovery was one of the great moments in modern astronomy, and yet it also produced one of the most persistent misconceptions. People hear black hole at the center of the galaxy, and they imagine catastrophe, a cosmic drain, a monster swallowing the Milky Way, a dark engine pulling everything inward in a single, unavoidable collapse. That is not what is happening. Sagittarius A times dominates its local region. Yes. It matters enormously in the central environment. Yes. But it does not vacuum the entire galaxy into itself. The stars in the Milky Way do not simply spiral helplessly toward the center. The galaxy is not a whirlpool ending in sudden annihilation. The black hole is a central object of immense mass, not an all-devouring cosmic vacuum cleaner. That distinction matters because it restores clarity at the exact place where myth is strongest. The galactic center is not a cartoon of destruction. It is a real physical region, crowded, energetic, dusty, difficult to observe, and anchored by a compact object of extraordinary gravity. Around it lie dense star populations, complex gas dynamics, and some of the most extreme conditions in the galaxy. It is dramatic, but it is not magical. And then comes the final correction, the deepest one. Human beings love centers. We love the idea that the center of something must also be the point of meaning, the seat of importance, the place from which the rest of the structure takes its significance. But the center of the Milky Way is only the center of the Milky Way. It is not the center of the local group. It is not the center of the cosmic web. It is not the center of the observable universe. It is not the center of reality. Even the darkest and most powerful known point in our home galaxy does not restore our lost sense of cosmic importance. If anything, it finishes the lesson that the rest of the galaxy has been teaching all along. We began with a band of light in the sky, a beautiful illusion of simplicity. Then that band opened into a disk. The disk opened into a halo. The halo opened into dark matter and hidden gas. The galaxy revealed satellites, streams, wreckage, outer distortions, inner density, and finally, a black hole buried at the center. And after all of that, the strangest truth is not that the Milky Way is large. It is that even something this large is still only local. Our galaxy stretches across distances the human mind was never designed to feel. It contains hundreds of billions of stars. It holds ancient globular clusters, stellar nurseries, dark matter, dead stars, living systems, and the ruins of smaller galaxies it consumed along the way. It is vast enough to erase every normal instinct about scale, and yet the universe did not arrange itself around it. The Milky Way is not the final frame. It is not the chosen structure. It is not the center of the cosmos. It is one galaxy, one immense, intricate, beautiful galaxy. One home, one address, one temporary island of light in a universe filled with others. And strangely, that may be what makes it more meaningful, not less. Because the Milky Way does not matter, because it sits at the center of everything. It matters because this is where consciousness opened its eyes inside the dark. This is where matter, after billions of years of collapse and fire and silence, became aware enough to look upward and ask where it was. This is where a species, born on a small world in a minor spiral feature, inside one ordinary large galaxy, in one local group, in one filament of a cosmic web, learned that home was real, but never central. The band of light in the sky was only the beginning. Behind it was a larger structure. Behind that structure was a larger context. And behind that context was a truth, both cold and beautiful. The universe was never built around us. And yet here we are, inside one galaxy, in one brief age of stars, trying to understand the shape of the darkness that made us. That is the Milky Way. Not the one we imagined, the real one. And the more clearly we see it, the less it looks like a familiar picture in the sky, and the more it feels like what it always was, a vast, layered, ancient system of light and gravity, inside an even larger universe that never needed us to exist in order to become magnificent.